listeners, and welcome to another episode of Climate and Conservation Conversations. A quick update. I opened a Redbubble shop with some of the basic merch for the podcast, but more importantly, there's some fantastic Science Not Silent stickers for various STEM fields, if you're feeling rebellious and frisky, which I think most of us are at this point in time, because the world's on fire and my bingo cards mean nothing at this point. Anyway, I hope you have enjoyed the previous News Roundup episode, which will be a monthly occurrence, but now I am shifting to some informational bits. I had started writing this last summer, and it was disgustingly hot, dry, drought-ridden, smoky, basically the standard Wild West anymore, unfortunately. Then I rewrote some in the pitiful winter, which we had basically hardly any white fluff. It lasted about a week, 2 weeks. It was pretty warm, minuscule. And now we're back to the heat. We just had our first heat wave of 95, which is 35°C for the rest of the world. And even worse, 106 back in my hometown. It was disgusting. And not the only place to have the heat wave. Heat waves suck. A warmer than it should be winter sucks. So we're going to swing to a climate-related episode. And it's a topic that's talked about to the point of exhaustion. But perhaps we're not really talking about it in the right way, or we're not explaining it well enough for people to care and understand the importance of it. A little vague, but the Earth is gassy, if you will. And if you haven't figured it out yet, we're going to talk about greenhouse gases, which is a conversation that tends to revolve mostly around carbon dioxide, that's CO2. That's only one of several gases that we monitor for. Why do we talk about CO2 the most, though? It's a little complicated, but not really if you frame it right. To get into that, though, let's talk a bit about what makes up our air. Even though we say we breathe oxygen, it's not just that. Roughly 78% of what we breathe is nitrogen, 21% oxygen, and the rest, which is that 1%, is a mixture which includes the greenhouse gases and obviously, some particulates. I can tell your next question might be something like, if they're only 1%, a tiny fraction of the composition, then why are we so focused on them? And that's a really good question. You should always ask questions if you don't understand something. There's no such thing as stupid questions, despite what your college professor might have told you. It's a very important conversational topic, and these gases are really good at trapping heat in our atmosphere, obviously. They're very good if they only make up 1%. Some have a greater hang time than others, and that's a notion that we're going to explore during this. Okay, let's frame it in a way that maybe more people are going to understand. Think of greenhouse gases like compound interest on your savings account. Most people can relate to something like this, or some people. When you deposit money, interest is added to your account, and that interest also starts earning interest. The longer the money stays on the account, the more it grows, and in a similar way, we release greenhouse gases in the atmosphere through activities like burning fossil fuels, using air conditioners, I know that's just a double-edged sword there, or deforestation. Those gases stay in the atmosphere for a long time. Over time, they build up, trap more heat, the gases accumulate, and it gets warmer. That's the general purpose of it, if that makes sense. I at least hope the analogy didn't fly too far. The main greenhouse gases are carbon dioxide, methane, nitrous oxide, and a group called the fluorinated gases, which are made up of a few different gaseous compositions involving fluoride, as you might have guessed from fluorinated. So let's go smallest to biggest as we learn about them. Just try to give you a little bit of info on each, and hopefully not overwhelm you. The fluorinated gases make up about 3% of the greenhouse gases and come from human-related activities. They're actually solely from human activity. These are released from various forms of manufacturing and things like refrigerants. Kind of ironic that we have to blast ACs to stay cool, and ACs release the gases, which then in turn heat things up, and that is the double-edged sword that I mentioned. The amount of them is fractional, but they have a long hang time in our atmosphere. Depending on which of the fluorinated gases it is, it could last weeks to thousands of years. They're significantly more powerful at trapping heat than carbon dioxide and are actually the most potent and longest lasting of the greenhouse gases. But on the flip side, the compounds are destroyed when they go into the upper atmosphere by the sun, so just kind of push them up. And it's a process called light-induced decomposition, so thank you, sun, for cooking us, but also helping to break down some fluorinated compounds. In the US, fluorinated gases have increased by 105% since the 90s, which is largely due to the increased use of hydrofluorocarbons as a substitute for substances that we use to previously deplete the ozone, the Smash Mouth song. Fluorinated gases are just kind of, man, they're just stealthy little buggers. That's one down. Next one, we're going to switch to our other contender, nitrous oxide. A little bit more concentrated than the previous gas, nitrous oxide makes up about 6% of the greenhouse gas emissions, but they have a shorter hang time with an average of 121 years, so that's still, longer than our lifetime. When it comes to their impact on warming the atmosphere compared to carbon dioxide, 1 pound of nitrous oxide is 265 times that of 1 pound of carbon dioxide. That's their impact. 265 times. Pretty damn significant. How much of this nitrous oxide comes from people and where's it coming from? And I'm glad you asked. Hey, another great question. Worldwide, about 40% is due to human activity, largely from agricultural land management, which means things like fertilizing crops and forest and grassland fires. And then we have manure management, which is something. Wastewater treatment, essentially humans treating things, whether it's our land, water, or burning fossil fuels. There's something called the nitrous cycle, which is a naturally occurring cycle. This is a process of nitrogen going through the atmosphere, terrestrial and oceanic systems, and then converting to just different forms, this being one of those forms. The inventory of U.S. greenhouse gas emissions in sinks notes that the nitrous oxide emissions dropped 3% in the states from 1990 to 2022, with a drop from vehicles contributing to about 56%. So that's awesome. Now, I don't want to bore you with numbers, but I do want to stress the extent of the impact that each one of these gases has. Hey, at least I'm just providing you the numbers. I'm not making you do the math, right? So we're going to talk about methane. And immediately you might think volcanoes or cow farts, because that's been a big topic. But it actually accounts for 12% of emissions in the US from human cause, which does include raising livestock. Manure can be stored in lagoons, holding tanks, and sort of, it's kind of human by proxy, because we're managing that, but yeah. The energy industry is also part of the contribution with natural gas as a fuel source, which is the second leading cause here, followed by landfills. As waste sits in these huge areas, just decomposing very slowly, similar to nitrous oxide, the emissions have decreased in 1990 to 2022. That is great. But waste is something we can work on. Consumerism is something we can work on. There's so much more we can do, right? Let's talk about the elephant, carbon dioxide. The big one, the one that everybody wants to talk about. So now that you know those other gases are small fractions of it, but they are long-term friends of ours. Carbon dioxide. It is different since it isn't really destroyed. Some of it's absorbed by the ocean, as we know. Some of it stays around in the atmosphere for thousands of years. As you likely know, fossil fuels are the biggest contributor to carbon dioxide emissions, and it accounts for 76% of the global emissions. Boom. Elephant. Just a few percent more strictly for the US, as it turns out. CO2 is also part of the carbon cycle, which is a cycle of how carbon moves through the atmosphere, soils, flora, fauna. Like fossil fuels, though, are not just for combustion engines to power our oh-so-useful vehicles. God, you know what would be great? High-speed rails. I want high-speed rails. So it's worth noting that the previous gases we talked about are all measured in parts per billion, whereas carbon dioxide is measured in parts per million. And you might first think that billion's a larger number. But in this case, that means it's more diluted. It's one drop out of a billion, and this is a drop out of a million. So obviously parts per million is a greater quantity. And in the past 800,000 years, the highest concentration recorded via ice cores is 300 parts per million. 800,000 years, that was the high. Would you like to know where we're at now? 427 parts per million at the time of recording. That's where we're at. Man, we're crushing it in the worst possible way. So the fluctuation is over thousands of years from that 300 level to the lower level of around 180, whereas we currently went from 280 pre-industrial, which is not honestly that far back in the geological timescale, to over 400 where we're at now. It's a very short time that we spiked it so much. Much shorter time frame. For the record, this is the point of the climate debate. No one is contesting that the climate changes. No shit. Have you heard of the Ice Age or dinosaurs? That's not the problem. The problem is that humans, with our disregard to the environment and thinking about ourselves because that's just how we are, we rapidly changed things for the worse. That is the whole debate. And honestly, it's really not even a debate. It's just people that refuse to acknowledge what we've done. Really, when we have these, quote, debates about climate change, it's anthropomorphic climate change. With all that being said, let's talk about also water vapor and how that contributes to the greenhouse effect, because that is something. And it's not really one that comes up, but it accounts for about half of the greenhouse effect, which is interesting. Water vapor, however, is important because of the water cycle. This is naturally occurring, yeah. The old water cycle that we should have learned about in elementary school at some point. I think it was like 4th or 5th grade when my school did it. Anyway, thanks to satellite data and other observational equipment from scientists and things, we found that water vapor is increasing 1 to 2% per decade and increases as the planet's temperature increases. So it's important to point out that this isn't the cause of warming. It's an effect of it. Effect. So let's go back to the water cycle and lay it out for you. Greenhouse gases mentioned previously trap heat. Then the Earth experiences warming. The warming then increases evaporation. Warm air holds more moisture. Hello. Humidity. We hate that. That's it. That's a feedback loop. It's called a positive feedback loop, which, just to quickly mention that a positive feedback loop increases the effect of the change, whereas a negative feedback loop reduces the effect of the change. So positive is actually bad here and negative would actually be good. So how is water vapor different from the other greenhouse gases? It's condensable. That means it changes form as the temperature changes, which, again, that's our water cycle. Humidity, it goes up, it gets cold, it condenses, we get rain, snow, whatever, So the water vapor goes up, up, up in the atmosphere, gets cold, condenses, forms a vapor to a liquid. The other gases don't do that. Obviously, They're just happy, bouncy little gases, just bouncing away. Anyway, because water vapor does this, it's the only greenhouse gas whose concentration increases with warming. That feedback loop mentioned, in effect. Now, unlike the other gases that hang in the atmosphere for a long time, water vapor lasts about 9 days on average. So to push this idea further, let's hop back to the water cycle. Because of how water vapor acts as a condenser, it increases the effect of the water cycle where wet regions become wetter, dry regions become drier. Something you might not know, when the ground gets too dry, soil becomes hydrophobic. And that probably means what you think. It means the ground is afraid of water, in a weird way to say it. The ground resists the water. It doesn't absorb it, it repels it. So think of a region that is plagued by drought, and then it gets hit with this heavy storm, and the water's not getting absorbed. It creates this flash flood. So, a whole bunch of gases and water. Yay, water. Water's great. But there's also kind of part of the, you might have seen news articles or headlines, if you don't read the articles, just talking about how it's going to be wetter here, and people are like, well, we get rain anyway. Yes, but this is part of the effect, that where you live, the conditions are amplified. Hotter, drier regions stay hotter and drier. Wetter regions become wetter. And it's a very big problem, depending where you live. We don't want the extremes to become the norms. There you have it. There's our gases, and here's a little fun, nonsensical fact about carbon, since we're on the topic. That carbon footprint that gets talked about a bunch all over the place. What's your carbon footprint? That was a scheme created by BP. Yes. BP Oil. To shift the blame to you, us, the average person, the average consumer, who's just going about their daily life trying to survive. Now, it's not to say we can't do better, because obviously we can. I mean, we have done better. Help. Like, take plastic bags, for example. They weren't really a thing until the 50s, and we did just freaking fine before them, didn't we? Yeah, we did. The world basically revolved on reusing and recycling in some part, which is kind of essentially something that my grandparents really had an influence on me, really instilled in me. I mean, my grandma still very much bought a sour cream container, and you're going to reuse that container, and I am totally like that too. But not only is plastic a menace trash-wise, it requires fossil fuels to be manufactured, which then, contributes to emissions, and so they have an pre- and post-production effect on the environment. Emissions and microplastics. Yay! So, did the planet pass gas? Yes. Yes, it did. No thanks to help from us humans, and there isn't exactly a gas X dose big enough to handle this. I know there was a lot to unpack in this episode. That was a lot of numbers. That was a lot of hard facts thrown at you. If it was overwhelming, that's okay. That's perfectly okay. And if you understood a bit of it, that's fantastic. But, it's a delicate balancing act trying to give the details without sounding like a textbook. And I hope it wasn't too textbook-esque, because that would just be cringe. But I also hope you got more insight into what greenhouse gases are and why we talk about them so damn much. Is the state of our planet getting worse for wear? Why? And with recent news about climate change from scientists, which I'll cover in the next news episode next week. If anything can be taken away from this episode, maybe it's just enough to let you be curious and a little more understanding when you see a headline about this topic. Think critically, ask questions, keep learning. Stay tuned for the news episode coming up, and remember, science, not silence. Till next time, Wolf out.